Hello everyone, welcome to the INS lecture series. This is lecture number 9, and in this particular session we will be covering the topics multiple encryption and triple DES, then meet in the middle attack which can be which can be done on this multiple encryption method, and then triple DES with 2 keys, and the last topic triple DES with 3 keys. In the previous session we studied about DES and of course AES in the previous sessions. So in this session we will have some enhanced version of DES. Now one of the suggestions for increasing the security of DES was to have multiple encryption. Okay, so because the main reason was that DES was vulnerable to brute force attack, because the key size was of course of 56 bits, and for security purpose at least a key size of 64 bit is required, but this only gives a key of 56 bit. So we need an alternative for this. One of the alternative was using the AES, okay, which we studied in the previous sessions, and the second alternative was using multiple encryption using DES with multiple keys. So we'll see this how we can actually enhance the DES. Okay, so the first version is of using double DES. So what is double DES? So double DES is a cryptographic algorithm that uses 2 iterations of DES to provide an additional layer of the security. So here we can imagine like we have 2 layers. Okay, we are encrypting, we are doing this encryption twice. Okay, so in because double, now there is some vulnerability with this also. So double DES is considered weak due to the vulnerability to certain attacks. There we'll see that. Okay, so of course it is not recommended. Now how this work actually, DES. So in DES it requires 2 separate keys. So we can assume this is K1 key and this K2 key. Okay, of course not a physical key. The key of course is some combination of bits. Okay, so there are 2 keys are used. Each key is of 56 bits. So there's 56, 2 different keys are used. Okay. Now see, this is how the double DES encryption is done. Okay, so this is the this block, it shows the encryption process. Okay, so for encryption process, we assume the plain text consists of course because it's a block cipher. So this plain text, this what we are given, we are giving providing to the first DES block is 64 bits. Okay, then it is encrypted using the first key, that is of 56 bit. Okay, and then the output of this is again encrypted using the 56 bit key. Okay, so here 2 keys are used, K1 and K2, and this is the final result, that is the cipher text. Okay, then this is the decryption process. Of course it is opposite of the encryption. So here this is the cipher text. At the receiving side we get the cipher text. So this cipher text goes to the first block, and first K2 is applied. Okay, and then finally K1 is applied. In this you can see the sequence: first K2, then first K1, then K2. In the decryption, first K2, then K1, and finally the plain text is recovered. So this is the basic idea. Okay, now this particular algorithm, that is double DES, okay, because we are using 2 blocks of DES, it suffers from this attack called as meet in the middle attack. Okay, now this meet in the middle attack is a crypt analysis technique which is used to break the double DES. Okay, so what the attacker does is, attacker takes the advantage the way double DES algorithm works. Okay, on data with 2 different iterations. Okay, now how it works actually. So here you can see this is how the attack works. The very first step is key space reduction actually. So in double DES we have 2 different keys. Okay, so this key, each key is of 56 bit. So the effective total key is actually 2 raised to 56 into 2 raised to 56, so it becomes 2 raised to 112. Okay, because we are using 2 different keys. So the effective key space is 2 raised to 112. Although the key space is increased, but the attacker actually takes an advantage, okay, of this, because here in this case what we observe is this process is totally reversible. Okay, so this P, whatever plain text we are giving, we encrypt it, we get a we get a partial plain text, we can say P dash, and this is again encrypted using K2, and we get the cipher text. So what the attacker does is the first phase, we can say, of this meet in middle attack is called as the pre-computational phase. What the attacker does in this is the attacker pre-computes the encryption of all possible combinations of first half of the plain text. Okay, so the attacker will take any of the plain text message. Let us take the plain text is suppose P. Okay, this can be any randomly chosen text. Okay, so attacker, out of all these 64 bits, the attacker takes the first half of this, okay, and encrypts it using all the possible key combination. Okay, the first encryption, because the key is of 56 bits, so there are 2 raised to 56 combinations. So what attacker does is, attacker takes the left half of this plain text, okay, 32 bits, and get all the possible encryption using this key. Okay, now what the result will contain? The result will contain 2 raised to 56 entries. Okay, each will contain ciphertext of 32 bit, because out of the entire 56 bit, the attacker is only encrypting the 32 bits. Okay, now the next is the search phase. Now in the search phase, the attacker encrypts all the possible combinations of the second half of the plain text using all the possible keys for the second DES encryption. Okay, so now what the attacker does is, the attacker takes the second half of the plain text and it encrypts this 32 bits with all the possible key combinations. Okay, so this is the second phase. Now the next phase is the matching phase. Now in the matching phase, the matching ciphertext and the corresponding 32 plain text bit block are found in the table. Okay, so that the attacker has created a table. Okay, one table from this pre-computation phase and one from this search phase. Okay, and the attacker tries to match this 2 columns. Okay, so there would be a particular matching pair. Okay, for that particular matching pair we get the 2 keys. So there will be a two different combination of keys where we get the matching pair. Okay, then what the attacker does after getting the matching pair, the attacker then uses each candidate pair of the key to perform the full double DES. Okay, this was partially. Now then the attacker gets the tries to get the entire double DES decryption. Okay, and then finally the attacker compares the 2 possible plain text for each candidate and sees if this match the original plain text. Okay, and in this case, this is how the attacker recovers the key 1 and key 2 using the meet in the middle attack. So this is the vulnerability. Okay, now we can have some more combinations of this encryption. There's triple DES. One of the ways is using triple DES. Now this is triple DES with using 2 keys. Okay, one more enhanced version of DES. Now in this case, as we can see, the plain text. Now why it is called as triple DES? Because we have 3 different blocks of DES. Okay, and we are using, because only 2 keys are used, we can see here K1 is used and here also K1 is used. Okay, so this is K2. So what is done is, the plain text is applied to the first block of DES. It is encrypted using the K1 key. Then the output of this K1 is again encrypted using K2, and the output is again encrypted using K1 again. So these 2 keys are same. Okay, so therefore it is called triple DES, but the number of keys are 2. Okay, so this is the working is explained here. So we only use 2 keys. Okay, because only 2 keys are required in this case. Okay, this is explained. This is what we are doing. Actually, this is the encryption process, and of course in the decryption process the reverse things occur. Okay, so in the decryption process, it is decrypted using the first K1, okay, then K2, then again K1. Okay, then we get the output. Now regarding the security, of course this particular algorithm also actually suffers from that meet in the middle attack. Okay, so this is of course a potential threat to this triple DES even using 2 keys. Now next we have triple DES using 3 keys. Okay, so the difference is, we can see from the block diagram itself, we have K1, K2 and K3. 3 different keys are used. So here we give the plain text. It is applied to the first DES block using K1. Output is applied to another DES block with K2 and the last one, so K3. So the effective key size increases, of course, because of 3 56-bit keys. Okay, so 56 plus 56 plus 56. So that is what the mathematics we have. Okay, so it becomes 56 plus 56 plus 56. The effective size of the key space increases. So 50, this is almost equal to 166 around. Okay, so it is much stronger than other DES methods. Okay. So that's all for this particular session. Thanks for watching.